Alright, so you're back for the part 2 of your average rate of change of quadratic functions notes. In part 1, we did examples 1 and 2. You are on page 68 of your notes. Okay? So you were supposed to have already done example 3. So let's go over example 3. I'm going to give you a tip because I've been teaching long enough that I know what you're going to do. And I've seen students do this tons and tons of times. Example 3 says for the function g of x equals x minus 3 squared minus 2 is the average rate of change greater between x equals negative 1 and x equals 0 or between x equals 1 and x equals 2. This is your function, including the minus 2. I suggest that you go ahead and you put a box around this or you put a circle around it. The entire function, so you don't leave something out. Otherwise, you're going to forget to write this minus 2 in your formulas when you plug it in, and you're going to get the answer wrong every single time. So, you need two intervals. You have the interval between x equals negative 1 and x equals 0 first. You need to know that rate of change. So we're going to calculate that first. If we know our x's, and we know our function, we get our y's by plugging those in. So you do g of negative 1. Everywhere there was an x, you plug it in. You do g of 0. Everywhere there was an x, you plug it in. Now you plug these into your calculator. So in my calculator, I'm going to type negative 1 minus 3 squared minus that 2. Because if you do not minus 2, not 22, you get the wrong answer. Enter. Negative 1, 14. That means x is negative 1, y is 14. There's your x1, y1. Do the same thing for 0. I'm going to just go into my calculator. Not that high. Choose it. Go change that negative 1 to a 0. Enter. When I plug in 0, I get out 7. So my next ordered pair is 0, 7. That's x2, y2. So I found my x and my y, but I need to know the rate of change. The rate of change, ROC, for this particular interval, is 14 minus 7 over negative 1 minus 0. Now you say, Ms. Slusher, you put those in backwards. You didn't put y2 first, you put y1 first. I did that for a reason. To show you, as long as you get the y's lined up and their correct x lined up with them, you're going to get the same answer. So let's plug this into our calculator for those of you that struggle with the calculator. N over D gives us our fraction. 14 minus 7 over negative 1 minus 0. I get a rate of change of negative 7. So that's the rate of change for this interval. I have a second interval I have to calculate. I'm going to calculate x equals 1 and x equals 2. So I do g of 1, plug it in. I do g of 2 and plug it in. So I'm going to plug these into my calculator. Luckily, I still have that saved in my calculator because I didn't clear it. I plug in 1, I get out 2. Plug in 1, get out 2. There's my ordered pair. Plug in 1, get out 2. There's my x1, my y1. Go back into my calculator. Change that 1 to a 2 because that's what I'm plugging in for x. I get negative 1. I plugged in 2. I got out negative 1. So my ordered pair is 2, negative 1. x2, y2. Now I need that rate of change. Rate of change on this interval is, I'm going to do it as the formula says, got a minus, y2 minus y1 over x2 minus x1. Type it in my calculator. N over D to get the fraction, negative 1 minus 2, down to the bottom, 2 minus 1. Enter, negative 3. Now the question is, which rate of change is bigger? If you think about the numbers, negative 7 and negative 3, well, negative 3 is technically a bigger number. But if you look at the front of your notes, so I'm going to close this and look at the front of my notes for a minute. When describing and comparing the average rate of change, positive and negative simply tells you the direction. Both of those rates of change are negative. That just tells me that my graph is decreasing. I look at that what's called the absolute value of my rate of change. That's the distance it is from 0. So this rate of change is going down by 7. This rate of change is going down or decreasing by 3. Well, what's greater? Decreasing by 7 or decreasing by 3? Decreasing by 7 is decreasing more rapidly. Therefore, that rate of change is larger. So, the rate of change between B/T, you can abbreviate, x equals -1 and x equals 0 is greater. Now you could make this really fancy if you were typing this on a test or your end of course test. You could throw in that rate of change is greater because it's decreasing by 7, while the rate of change between x equals 1 and x equals 2 is only decreasing by 3. Now, let's look at example 4. Example 4, what's different about it? What's different is they give you a table. So we've used points, we've used a function itself, we've looked at a graph. Now we've got a table. Find the average rate of change between x equals -0.75 and x equals -0.25 for the following function. Well, if I need to know what x equals, if I know x equals -0.75, how do I find its y? I look in the table. X equals -0.75, its y is 3.5. That's important to me. So one of my order pairs is -0.75, comma, 3.44. You say, can I round? No. They gave you 2 decimal places, so you have to round to 2 decimal places. My second point, -0.25 is right here. What's its y value? You get that from looking beside it, -0.25, comma, 8.44. Rate of change, you're going to use the slope formula here as well. x1, y1, x2, y2. So let's plug that in. Rate of change equals, I'm going to put ROC. Rate of change equals. Got to have that minus. y2, 8.44. y1, 3.44. x2, -0.25 minus -0.75. What does minus and negative mean? Minus and negative means plus a positive. I'm not even going to deal with trying to put that in my calculator, the minus the negative part, because I am going to put this in my calculator, exactly as I see it. So, get these side by side here. Here's my calculator. Fraction bar, 8.44 minus 3.44 over -0.25 plus 0.75. Enter. My rate of change between these 2 points on this interval is 10. That's all I have to do. They tell me the interval of my x's, I find my y's, and I do rate of change, the slope formula. Now the last example I have for you is example 5. Example 5 says, consider the functions f of x equals x squared plus 5x plus 4. And g of x equals -x squared minus 4x plus 3. You have 2 different functions. You have f of x, you have g of x. Which function has the greatest rate of change over this given interval? So you say, well, what do I need to do? I need to get rate of change. For what? For f of x between -1 and 0, and for g of x between -1 and 0. So let's find the rate of change for f of x. Okay, this is how we're going to do it. We're going to take f of x. We need f of -1. We need f of 0 because that's the interval we were given. Here's f of x. For every x, we're going to plug in our variables. We know in this one it's -1. We know in this f of 0, it's 0. Well, how am I going to get this answer, you ask? You got it. We'll plug it in the calculator. So I'm going to do -1 squared plus 5 times -1 plus 4. Enter. I got a 0. That's my x. That's my y. Okay, I'm going to go back in here and I'll plug in a 0. I'll get rid of that 1 because I don't want it there. I'll plug in a 0, get rid of that 1. When I plug in 0, I get my 4. So my ordered pairs here are -1, 0. You plug in x, you get out y. They have to go in alphabetical order. Plug in 0, get out 4. So let's do my rate of change up here. Minus. y2, well, this is x1, y1, I'm sorry. x2, y2. y2 minus y1, 4 minus 0. x2 minus x1, 0 minus a -1. Minus a negative automatically go positive. You should be able to do this in your head. 4 minus 0, 4. 0 plus 1, 1. 4 divided by 1, 4. So what we found here is important. It's not our final answer. That's the rate of change for f of x. Now, we need to find the rate of change for g of x. Rate of change for g of x. G of x is a totally different function. Here's g of x. So f of -1, because I need the interval of 1 to 0. So I plug into g of x, -x squared minus 4x plus 3. You say, oh my goodness, Miss Lesher, that's a different formula. Yeah, because it's a different function. This is g. Okay, so I'm plugging -1, -1, 0, 0. So I grab my calculator. I can't just change these numbers because I have a different formula. So negative parentheses -1 squared minus 4 times -1 plus 3. Enter. I get 6. So I plugged in -1, I get out 6. I go in here, I change all these to a 0, get rid of that extra number. Change it to a 0, get rid of that number. I got a 3. 0, 3. Now I need my rate of change. y2 minus y1 over x2 minus x1. Oh, we got minus a negative again. Got to get rid of that. So, 3 minus 6, that's -3. 0 plus 1 is 1. What's -3 divided by 1? -3. Here's the rate of change. Now, which rate of change is greater? The rate of change of f of x is greater. Not because it's positive and this is negative. This rate of change is increasing by 4. This rate of change is decreasing by 4. I'm sorry, by 3. Positive, negative doesn't matter. What matters is the number itself. If you increase by 4, that's more of a rate of change than if you're just decreasing by 3. So, we're going to write f of x has the greater rate of change between x equals -1 and x equals 0 because it is increasing by 4, which is greater than a decrease by 3. This is what I am looking for in this video. There you have it. There's your average rate of change.